You can use the logical operators shown here to compare two expressions. First one listed is A and B, and this returns true if both A and B are true, and it's a binary type operator, requires two operands. A or B returns true if either A or B is true, or both. That's also a binary operator. You can use the bang operator, returns true if A is not true, so it's essentially returning the logically opposite value of A. So if A is true, it returns false. If A is false, it returns true. And then there's the exclusive OR operator, A caret B. And this returns true if either A or B is true, but both cannot be true. A and B with two ampersands. This one is sort of interesting. It returns true if both A and B are true. So far, it's the same thing as A ampersand B. But it varies in that it doesn't evaluate B if A is not true. Now, the reason for that is that if A is not true, then the expression can't be true because both A and B have to be true. So it doesn't bother evaluating B. Now, if it's just a variable, if B is just a variable, that's not going to be a big deal. But if it's a big, long, convoluted expression or a method that executes and takes forever, that's going to make a difference. And then similarly, A or B, the last one in the table with two vertical bars, returns true if either A or B is true, but doesn't evaluate B if A is true. Because if A is true, then the expression is going to be true, so it doesn't need to waste time evaluating B. So some interesting, sometimes somewhat subtle differences between the first two in the table and the last two in the table. Okay, so let's explore those differences just a little bit more. So the difference between the two is kind of subtle, but it's a very important difference. Now, the operators with the single characters evaluate both expressions. So both expressions on either side of the operator. And then it compares their values and returns true or false for the expression as appropriate. So the single character operators are the ones that you probably expect are the norm, the normal behavior for an AND and an OR operator. But then the double character versions of the operators, again, ampersand, ampersand, or vertical bar, differ in that they don't evaluate the right side expression if it's not necessary. For example, and returns true only if both expressions are true. But if the left side expression is false, the overall expression will be false. So there's no need to evaluate the right side expression. Similarly, with the double character OR operator, if the left side expression is true, the overall expression will be true, so there's no need to evaluate the right side. Okay, so make sure you understand those differences. Now, with simple expressions that compare either literal values or the values of variables, the difference between these two is meaningless. But if the two expressions that are being compared are really the values resulting from the expressions, if those expressions call methods that perform some operation, then it may matter whether both expressions are evaluated at runtime. This could have unintended side effects. So you want to make the right choice here. And often, your code is more efficient if you don't unnecessarily evaluate the right side expression, which could require a significant time to execute. If the right side expression is a method, as I mentioned, that takes a long time to run, short-circuiting the process so that you don't have to run that method can save a lot of time and can make your programs perform much better. Here's some code that shows how to use the logical operators. So I define various numbers, number 1, number 2, number 3, and number 4, set them equal to different values. And then I have author 1 and author 2. Both of those are set to Don and Paul. And then I use these logical operators in order to test various conditions. So if number 1 is less than number 2, that side is true. And if number 3 is less than number 4, that's also true. Both of these expressions get evaluated because I'm using the single character version of this, and it returns true. And because it returns true, this condition of the if clause is true, and so it executes this line of code. Both expressions are true, and it displays the different numbers. All right, then I have an author variable called Paul. And if author is equal to author1 is equal to Don, so Paul does not equal Don. Author equals author2, Paul is author2 equals Paul. So in this case, this is false, and this is true. Because either one of these expressions is true, the overall expression is true because I'm using the OR operator, and both of these get evaluated, and it displays that either Don or Paul wrote this example. All right, now I'm comparing whether number 1 is greater than number 2. But I'm using this bang operator to reverse the Boolean value of this expression. So number 1 is greater than number 2. Number 1 greater than number 2, that returns false. So inside this parentheses, that returns false. But then I negate that value. The value here for the if clause ends up being true, and this code executes. Okay, moving on to the exclusive OR. If author1 equals Don, author1 does in fact equal Don, or author2 equals Paul, author2 equals Paul, this returns false because both of these expressions return true. But this operator returns false if both are equal to true. Okay, so this code won't execute. And then if author1 equals Andy, that's going to be false. And author2 equals Paul, so this expression is false. This expression is true. But in this case, author1 does not equal Andy. This is false. The overall expression cannot be true, so it doesn't bother even evaluating this expression. And as a result, this line of code does not execute. Similarly, author1 equals Don. This is true. In this case, because this is true, and this operator is going to return true if either of these expressions return true, it doesn't evaluate this expression here at all. So I'll go ahead and press F5 to run this, and press K. And you can see that, first of all, I only get 4 lines here because not all of those if blocks executed the code because the condition in the if expression was false. So both expressions are true, 100 less than 200, 1,000 less than 200. Either Don or Paul wrote this example. 100 is not greater than 200, and Don wrote this course. So there are the results. Now with the logical operators, you're really starting to see some of the more complex features of C# programming. The sample code that I just showed you was comparing single values of variables, but you can use the operators to compare the values of complex expressions as well. Each operand that you use with a logical operator can itself be a complex expression consisting of many levels of logical and other operators. And with C#'s relatively terse syntax, this can make for some hard to understand code. So I really urge you to try not to be clever with how you build expressions. Keep things simple, and you'll keep them maintainable. Break complex expressions up into multiple statements if you need to, in order to keep things clear. Next up are the type operators. And there's really one operator and one method that I want to talk about here, because the method essentially does a very similar sort of a thing. So the operator is the is operator. And this is useful when you work with objects and you don't know ahead of time what data type an object represents. So you want to use the is operator in order to test whether an object is of a particular data type. It's sort of similar to equality or inequality for types. And then there's also the getType method that lets you determine the type of an object. It actually returns a value that identifies what type that object is. Here's some code that tests those type operations. So I'm declaring an object1 variable of type object. And then I'm setting object1 equals to 7. In this case, C# considers the number 7 to be an integer, and so it tests to see if object1 is int, which this essentially means for an object variable to test to see whether the value that it contains is an integer. And if it is, it's going to display that message right there. And this time I'm explicitly setting this to a decimal value by including the m suffix. So object1 now contains a decimal. Keep in mind that a nice thing about an object type is that I can save any kind of data to it. So I can test to see if it is a decimal, so there's that is operator. And if it is, it'll display this message. And then I set it equal to a string, test to see if it's a string, and then I display whether or not it's a string. And then finally, a float. All right, so that's the is operator. This last little bit of code uses the getType method. So I'm setting object1 equal to a floating point value, 2045.75, and I know it's floating point because I have that f suffix on the number. And then in the console.writeLine statement, I'm displaying the value of that object1, so that's going to display 2045.75. And then here I'm going to get the type. And this is going to return a string that identifies the type of object1 with this data. All right, I'll press F5 to run the code. And this time select L for type operators. And you can see object equals 7 and is type integer, is type decimal, Tuesday is a string. And then here you can see that I have this value there, and then it's of type system.single. So this gives you a lot of flexibility in determining the current type of a variable. So the is keyword is useful when you work with the object-oriented features of C#. Often you'll need a custom hierarchy of classes, and you need to test whether a particular object belongs to a hierarchy. And getType is useful in all sorts of situations where you need to deal with different kinds of data stored in any variable, whether the data type is object or any others. So it'll really just be with experience that you'll learn when it's best to use either of these. But basically, if you need to test it as a condition, you want to use is, or if you just want to return the value as a string, then you use getType. And certainly, you can use the return value of getType in a conditional expression as well. You just need to compare it to a string. All right, at this point, we've looked at a number of different operators that are available in C#. And you can use the C# operators to build very complex expressions that could involve dozens of variables and a similar number of operators. And you can really effectively build them arbitrarily complex as you need them to be. Operations are performed by your code in a certain order based on built-in precedence. For example, multiplication takes precedence over addition. This means that the expression 10 plus 20 times 30 is equal to 10 plus 600, or 610. And that's because multiplication occurs first, followed by the addition. So it's multiplying 20 by 30, 600, and then adding 10 to it. And the expression 10 divided by 20 times 30 is equal to 0.5 times 30, or 15. And that's because operations of equal precedence, except for assignment operators, that's a special case, are always performed from left to right, and division and multiplication have equal precedence. And about assignment operators are always assigned from right to left, which makes sense. You have to evaluate the expression on the right side of an equal sign, an assignment operator, in order to set the value of that variable, presumably a variable that's on the left-hand side. Okay? So hopefully you can see that that's the proper way for things to work. All right, now, so you have this built-in precedence, and precedence matters. The order of operation matters. And again, 10 plus 20 times 30, if you do the addition first, that's going to be a different result than if you do the multiplication first. So you can certainly write your expressions very carefully to make use of the built-in operator precedence. But this can be a problem because the rules are sometimes complex and somewhat unintuitive. So a better way to write code is to make the precedence explicit, which also lets you override the rules. And you do this by using parentheses to control how operations occur. So for example, you could use 10 divided by 20, put that in parentheses, times 30, to multiply 0.5 times 30 in order to make explicit the built-in precedence. So this is as you're scanning your code, you see the 10 divided by 20 in parentheses. You see, okay, that's going to execute before the multiplication. I understand what's happening here. But that's the same order of operations that you would get without the parentheses. The benefit being that now you can scan the code quickly and see exactly what's happened. You don't have to stop and think, oh my gosh, is division higher precedence than multiplication? I got to go look it up. No, I think they're equal. Maybe they're not equal. You don't have to remember all that stuff. Okay, alternatively, you could use 10 divided by the 20 by 30 in parentheses to override the default precedence. And now this is going to result in 10 being divided by 600 because the parentheses dictate that the 20 times 30 is going to be executed first before the division occurs. And now the expression evaluates to 0.016666666666 and so forth. Okay, so this can be a little bit confusing. So you can use the built-in precedence. Now, these are most of the operators that you learned about so far, a couple others. And there are other operators in C#. So you're going to want to check the C# operator documentation on MSDN to see how they all fit together. There's a whole bunch of other operators that I haven't covered yet. The way this works is that the operators in each row have equal precedence. Doesn't matter the order in which they're listed. In the first row, the plus, minus, bang, plus plus x, minus minus x, all of those are equal. And so those are going to be evaluated from left to right. And then looking at the table, the higher the level row, the higher the precedence. And so you can see right off the bat that assignment operators are at the bottom, which is good because you want the entire expression on the right side of the assignment operator to be evaluated before you make the assignment. If you did it the other way around, if assignment has the top level precedence, then the assignment would occur with only the leftmost operand in the expression on the right-hand side. And so there would be chaos. All right, so you can see that the unary operators, plus and minus, which change the sign of a number, minus to plus and plus to minus, have a higher precedence than multiplication or division. Multiplication or division has higher precedence than the plus and minus binary operators. Comparison operators have the next level precedence, and then on down the table. Here's some code that has some simple examples that indicate how this operator precedence works. I'm going to run the example so we can look at the results. And I'll press M. There's the results of this code. All right, so I'm declaring various values here. First amount equal 100, second amount 200, third amount 300. And here what I'm doing is I'm making some comparisons and using the AND and the OR operators. So this operator, if you recall from the table that I just showed you, has higher precedence than this operator. But these comparison operators have higher precedence yet. So the way this is going to be evaluated is, in fact, left to right. So it's first going to evaluate is first amount greater than 50. First amount is 100, so this is true. Then it's going to evaluate this expression. Is second amount greater than 300? It is. And in fact, this expression will be evaluated because this is AND. This is true, and so it has to test to make sure this is true. Second amount is not greater than 300. So this part of the expression returns false. And then it takes the result of that expression, which is false, and uses this OR expression to check third amount. And in fact, this expression will be evaluated because even though I have the double OR logical operator here, this is false. So the overall expression could still be true if this is true, and in fact, that expression is true. So the overall value of this expression is true, and this code executes. And so we see that first amount is greater than 50, and also either second amount greater than 300 or third amount is less than 500. So this code executed. Okay, then I'm going to override with parentheses. But actually what this does is it doesn't override it, because this is just reinforcing that this is going to evaluate before this. But it does anyway, because and has higher precedence than this form of OR. And so this code once again executes because this results in the same value.